This equation is already one of my 4 standard forms because I've got a nice clean 1 downstairs as my first term, but e is equal to 3, which is bigger than 1, so I know I have hyperbola. So let's sketch the hyperbola. Identify intercepts, identify foci, but also let's see what I determine the rectangular equations of the asymptotes. Now, very much like with an ellipse and a parabola, I'm merely going to play the game of identifying location of intercepts. They're so darn easy. Now, if I look at the direction of pi halves or 3 pi halves, their cosines are 0, and I'm left with a radial distance of 8. Looking straight at the polar axis in the direction of 0 radians, its cosine is 1, so r is equal to 4. If I look down the negative x-axis in the direction of pi, its cosine is -1. My radial distance is negative. Uh-oh, I've lost it. So I think I have an arithmetic error. Can I look at that 4 again? My apologies. If theta is 0, its cosine is 1. My denominator is 4. Isn't that radial distance 2, not 4? My goodness. Now, looking in the direction of pi, that's -1, and the radial distance is -4. Got my arithmetic straight. So look in that direction, standing at the pole, let's walk -4 units. There's a polar point at that point. Sorry. There's a polar representation at that point. Now, I already know that I got a hyperbola, so I know one branch has to wrap around one of the foci. But one of the foci is for free at the origin since I've got one of these standard forms. That means the other branch passed through that vertex, has another focal point somewhere over here, but the location of the focal point is easy to find because the distance between this focal point and this associated vertex is 2 units. So the distance between this focal point and this associated vertex is 2 units. Does that mean my foci could have this as its polar representation? Now, the only thing I'm missing is the location, or the equations, I should say, of the asymptotes, but it looks to me like I put that in an awkward position on the board. Can I bring it up here? Much better. Now, the equation of the asymptotes look like this. Unless you want to generate these equations simply in rectangular form. So I need 2 things. Well, 3 things. X naught, Y naught, and M. X naught and Y naught are a piece of cake. Center is located halfway between these 2 vertices. I'm too tired. It's also halfway between these 2 foci. So I think it's going to be located at the rectangular point 2, 0. And that, uh-oh, I've got the wrong ones. Sorry. Halfway between these 2 foci, here and here. But halfway through is going to give me a rectangular point of 3, 0. The only thing left is the slope. But wouldn't you agree that when it comes to this asymptote, or the other one for that matter, that if I plant my feet, I have to pull and look in the direction of that look in the direction of that asymptote. Let me start that over again. If I plant my feet at the pole and look in the direction of the asymptote, is it not true that I'm not going to get a corresponding point on the Conics section? I think there will be no corresponding R value when I look in the direction of the asymptote. And so look in the direction of the asymptote, I should come up with an undefined R value. But R is certainly undefined when the cosine of theta is -1/3. And so theta is the inverse cosine of -1/3. Can I just look at this reference angle? Let's go ahead and let theta be equal to the cosine inverse of 1/3. Draw myself a nifty little triangle. So doesn't that mean then the slope is just going to be rise over run? That's this over that. There are the two equations of my asymptotes in rectangular form. I think I will choose that to be the very last question I ask.